Can I have a sheet, Jolie?
Yes. Alright, so today we are doing 8F, and so we are still continuing on with geometric sequences which relate to compound interest, unlike linear sequences which relate to simple interest. And we are multiplying, so we have a ratio. So we're continuing with geometric, and today we are looking at the rule for geometric sequences. So we looked at the rule for, oh my goodness, mind blank, linear sequences when we had the A plus ND, N times D. So we've got a rule for geometric, and we use this rule to find the nth term or to find any term that's not consecutive. So when we're not asked to use recursion, we can use this rule. Is that making sense? That was probably the most wordy explanation I think I've ever given on that topic. But anyway, okay, so we can use the rule that doesn't have a name. So as per what we did with linear and with when we were doing recursion with geometric, V0 is our starting value and R is our ratio. And when we know the ratio, this is our rule. So it's our ratio to the power of n times V0. And n is the number of years or the number of terms. Any questions so far? So we use this one when we're trying to find the 45th term, the 63rd term, the 10th term, or the nth term. Okay, if we are given the rate, this is our rule. So the only difference is this bit in here, which we talked about last lesson. So we did this rule last lesson, which was just the 1 plus R over 100, when we were given the percentage rate and we needed to turn it into a ratio. Remember doing this? Yep, so this was rate into ratio. And this whole bit, which is this bit here, is just in place of the R, because we don't know the R. So we need to do this bit first. If you prefer to find the ratio first and then use this one, that's absolutely fine. It does the exact same thing. You can either do it in 2 steps or you can do it in 1 step. Just important to note that if we're increasing, we're using a plus, and if we're decreasing, we're using a takeaway. It's the only difference between these two. Any questions about those 3 formulas? So these are all the rule, all 3 of them. Just depends whether we're increasing or decreasing and whether we have the rate or the ratio. This one we can use whether we're increasing or decreasing. It's the same thing because we already have the ratio that we're multiplying by. Whether it's 1 point something or 0 point something. Can I move down?
Yep.
All good? Cool. Okay, just a couple of things to note. Just like when we were working with our linear sequences, if we're asked for the nth term, we need to write the rule in terms of n. We need to keep n in the formula. So just like we did with the linear rule. And then if we're asked to find the 45th term, we sub in 45 as n. So there might be 2 things that you can be asked. You might be asked to write it in terms of n, or find the nth term, or write it in terms of the 45th or the 63rd, or just whatever relevant term they want. Does that make sense? Anyone confused by this nth term? No? Cool. All right. One thing that we need to make note of is when we're using compound interest, we'll often be asked to find how much interest has been earned. So when we're using compound interest, to be able to find how much interest has been accumulated on the principal amount, so not including what we've already put into the bank, we need to subtract the principal amount from the total amount we have found using the rule. So what that means is when we use compound interest, it tells us what the total is going to equal. If we're asked to find only the interest, we need to take out what we actually put in there ourselves, because we didn't earn that, we just put that in there. That's not interest, that's the principal amount. Does that make sense? Because compound interest will give us the answer as principal plus interest. Does that make sense? Cool. So if we're asked to find interest, we need to do that little step there. So if we're asked to find interest, just the amount of interest that's been earned, we've got the total amount, take away the principal. The total amount it's earned in however many years we're looking at, take away how much we originally put in the bank, or the investment, whatever we're talking about. Any questions? All good? Cool. Can I move down? Yep. Okay, and we just have a few examples to go through, and they shouldn't take us too long because I've already done this sort of stuff before. Okay, a principal value of $10,000 is invested in an account earning compound interest at the rate of 9% per annum. The rule for the value of the investment after n years, Vn, is shown below. So this is the rule we've been given. It's not recursion, it is the rule. And we can see that because it doesn't have the Vn plus 1, it doesn't have the V0, it's just got the rule. It's just saying whatever the nth term equals 1.09 to the power of n times 10,000, which is our V0. So that's the rule we've been given. Any questions about that? Cool. All right. So find the value of the investment after 4 years, correct to the nearest cent. So after 4 years, so our n equals 4. So wherever there is an n in our rule, we're going to sub in 4. So that was our rule. And we're going to sub in 4, power of 4. And so our V4 5.8. After 4 years, the value of the investment is $14,115.80.
Do you put a 0?
No, because it only says nearest cent.
Oh, okay.
Yeah. Oh, hang on. Nearest cent.
It says 0.
Yes, 0. Sorry, cent. Yeah. Nearest cent would be, because we've got 10 cents, 11 cents, 12 cents. So it should be 2 decimal places, because cents is 2 decimal places.
Yeah.
Money, we work with 2 decimal places.
Yeah.
So it should be, sorry, that was my mistake. It should be 2 decimal places if it says nearest cent. Okay, so find the amount of interest earned after 4 years, correct to the nearest cent. So this is just finding how much interest have we earned. So that's why we need to use that little formula we just wrote down before. So our interest equals our total amount, take away the principal amount, so what we started with. So $14,115.82. Take away $10,000 because that was our principal amount. So the amount of interest we have earned is $4,115.82. So after 4 years, the investment $4,115.82. Any questions with that one?
Do you need to say has earned interest or just earned?
Oh, yeah, has earned, sorry, yeah, interest, yeah. Thank you.
Did you say? Damn, I lost my voice. Come back. Would you say interest?
Yep, that's how much interest it is earned. Yep. Okay, so this question is asking how much interest has been earned over 4 years. Yeah, over the 4 years. So from when we first put it in to after 4 years, how much altogether has been earned? This next question is asking, find the amount of interest earned in the 4th year. So only in that 4th year. So from the 3rd year to the 4th year, how much has been earned? So to find that, just in that year, we first need to know how much was in the 3rd year. How much we earned in the 3rd year. So we need to know how much altogether we have in the 3rd year.
Would you not just divide the previous one by 4?
No, because when we're compounding interest, it gets calculated on the previous term. Because remember we go like that.
Oh, yeah.
If it was linear, yeah, sure.
Okay.
But not geometric.
Yeah, because it's different from accounting.
Sorry.
It's like the same thing, but it's just like
You work it out differently.
Yeah.
Well, if you girls get the same
Same
answer
answer.
doing it how you do it, that's fine.
Yeah.
Okay, so we
Yeah. Yeah, that's absolutely fine. Just as long as it's recursion or whatever, you do that. Yeah. So we sub in 3. And we get so after 3 years, this is how much money we have in the investment. So to work out how much has been earned between the 3rd and the 4th year, so in that 4th year, we're going to go our V4 total, take away our V3 total. That's not the total. It's the total.
14.
Yeah, thank you.
Do you have to write the dollar sign or not when making?
In your answer, you probably don't have to write it there if you don't want to. And what did I get? 1, 2, 9, 5, 0, 2, 9. The amount of interest earned in the 4th year was $1,165.53.
Should you always write a sentence after?
Yeah, just explaining your answer. Yeah. Any questions? All good? Cool. So the next one, if the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. So this is when we go back to what we learnt last lesson. Was that yesterday?
Yeah.
It seems so long ago. Oh my goodness. Okay. So when we were talking about, yesterday we were talking about when it's monthly, we needed to divide the rate by 4. When it was, monthly divided by 12, quarterly divided by 4, 6 monthly or half yearly divided by 2. So how many times we are actually paying it in that month. Does that make sense? So if we have, so for our ratio, so to find our ratio, we need to use our rate, which was 9%. And, let me just write the formula first. So we'd have rate over payments per year. So this is the formula we are using to find our ratio. So we've got the rate
Oh no, it's just from the shop.
over the payments per year. So we'd sub that in. So our rate is 9%. Bless you.
Thank you.
Oops, maybe that one. Over 12, because we're doing it monthly, there's 12 months in a year, so we're going to pay it 12 times in a year. And we get 0.75%. So this is what percentage we are using per month. This is our per month percentage. To find our ratio, we then need to put it into our ratio formula. This one, which we've seen before. And we're using the number we just found as the R.
Doesn't that first formula have a ratio there as well?
It does, but we need to write a rule for it.
Okay.
Yeah. So you put that whole bit into your calculator, and we've got 1.0075. This is the ratio we are using in the rule. Because the question's asking, write down a rule for the value after n months. So we still need to write our rule, which is in the form of this. Yep.
Why do you have to do the first thing first, like the ratio? Because rate over payment.
This bit.
Or, yeah.
Or you could probably put it in there as one go.
Could just put the 9 over 100.
9 over 12 over 100.
Oh,
You must have that 12, otherwise you'll get the wrong answer. All right, so then we've got our rate, which is 1.0075 to the power of n times our start, which was 10,000. So that is the rule. Who feels like there's just numbers being thrown around everywhere? A few people? All good? I feel like I'm just throwing numbers around everywhere.
That's what I'm saying.
Any questions? Okay, and then I might just do the last question over here instead of moving it all down and rubbing it all off, just because we need that and we can just see how it continues. So the next bit says,
That's why I like this.
oops, use this rule
So we've done SBAC.
last week of school,
As in,
this
not the
term.
Friday though.
The Because we're having a party.
Yeah, we're having a party.
So Thursday?
I'm unsure what day it will
Just not Friday.
be.
Not right. Party's more important.
How much is it
Literally.
worth?
Sorry. Do you go?
No, not off the top of my head.
Yeah.
All right, so the question says, this is question E, that's on the bottom of your sheet. Use this rule to find the value of the investment after 4 years. Now, because we are doing this monthly, that's 48 months. And we get 48 by going 4 times 12. So if it doesn't give you the months, that's how you find
Does
it.
it usually give you months?
Sometimes it will, sometimes it won't.
Do we at V48?
Yes, you do. So we start by, we've got our rule. So our rule is this, and I've just taken that straight from down here that we found before. And we are subbing in, oh gosh, we are subbing in 48. Because our ratio is so small, even though this looks like, oh my gosh, the power of 48 is going to be a huge number, because our ratio is so small, we're not going to get a humongous number. It will still be something similar to these numbers, but it should be more. But it shouldn't be too far different. So put that into your calculator and $14,314.05. So we can look at these two. So this is after 4 years monthly, this is after 4 years yearly. We can look at these two and be like, yeah, they're pretty similar numbers. They're both around 14,000. So this calculation must be pretty good. But this one should be more than this one. And we can see that, yes, this is more than that one. Does that make sense?
Yes.
Yep. Cool.
Because it's more years. More months.
More payments.
Yeah.
Yep. All right. Any questions with that? All good? Cool. Can I move down?
Yes.
Do you want to come? Wait.
Okay. Anyone still copying? No? All good? Okay, so, oh, I haven't written that recursion relation in.
I'm not right at that. Mum's not here in.
Yeah, I know.
I was excited. You know, my pink card. She said she likes the green. In black. When I see the stripes. It's actually it's nice.
You didn't get it.
She bought the green because it's $2 a meter.
500
Just to practice.
Like a version.
Yeah.
It's been.
Okay, so this one, we've got a computer system cost $9,500 to buy and decreases in value with a reducing balance depreciation of 20% per year. A recurrence relation that can be used, not sued, to model the value of the computer system after n years is V0 equals 9,500, Vn plus 1 equals 0.8 times Vn. So because we've got a 0.8, we should know that our numbers should be getting lower, smaller. Yep, cool.
Decreasing.
Decreasing, any of those words. Okay, write down the rule for the value of the computer system after n years. So, doesn't matter whether we're going up or down. We should be using the same rule. So our R for this one we've been given here. So it should be 0.8 n times our, oh hang on, we don't need that if it's a rule, do we? Oh my goodness, Friday brain.
Wow.
Sorry.
Don't worry about it, just roll my paper. I'm kidding.
That's it, just go with it.
Go ahead,
Just wing it.
Thanks.
You know what, just wing the whole year. Just, don't even come to class, guys. He'll be right.
Oh my god, I stuffed it again.
Do you reckon you could still pass BCE by not doing anything?
Depends on if you actually pass.
I reckon you can pass, but I don't reckon you get a good mark.
Depends on if you're smart.
Pass?
I don't think you could. If you were doing something
I
like
reckon you could if you're smart.
bio
Or like legal. If you did legal and you've never done it before, you fail.
Yeah.
Alright, use the rule to find the value of a computer system after 8 years. Write your answer to the nearest cent. So this means that our n
or 2 decimal places.
is going to be 8, and we're going to sub in n.
So much fun. Just like last Friday when I was like, let's go.
We'll get through this one.
There's just so much.
Okay, so sub in the 8, and our answer should be
Me too.
Same. I just want to be like,
How long does it take you to make one of these?
Yeah, that's a solid question.
Is it?
you can tell the ones that I've taken more time on because I've got less mistakes in them. So after 8 years, the value of the computer system is $1,593.84.
You come up with these stories?
Yep.
Really?
Straight from the textbook.
Imagination.
Straight from the textbook.
yeah, love.
Damn. Should have taken that credit.
Yeah.
With the rule.
Yep.
Can we write VN plus 1 before it?
No, not VN. You can write V. Not VN plus 1, but you can write VN.
Okay.
But not plus 1.
Really? You can just sit there and do it.
Okay, so calculate the total depreciation of the computer after 8 years. So this is like when we were asking about find how much interest has been accumulated. This is now finding about how much has the value gone down. So this is what it's worth. We need to find out how much has it gone down by. So pretty much what we did before. So it should be our, but it's going to be backwards. So principal, take away.
Literally.
That's not interest, that's depreciation.
Why
Is
didn't it come in?
principal take away. Take away the depreciated amount. So the principal amount was 9,500. That is an expensive computer. And the depreciated amount is $1,593.84. Everyone okay with where I got those numbers from and what we're doing?
Yes.
And
Yeah, not gonna lie, I'm just.
principal. So
That's helping Kate get ready.
1,593.8
K.
equals 7,906.
So pretty much this question is asked, how much has the price gone down
You're a piece of.
in dollars? So how many dollars has it gone down by?
Where did you get that
That's what depreciated means.
the formula?
Sorry?
Where did you get the principal minus?
That one? That's just sort of the opposite of what we were doing for the interest. So I would write that down.
So we should, okay.
Yeah.
So depreciation equals, okay. Are you laughing at me? I just need to get it in my brain.
So it's pretty much asking how much has it gone down in value? How much money?
Why is that? It's not a very great, isn't it?
Either way, she said it. Appreciation.
Okay, any questions there? Cool. Can I move down?
No.
No? Okay.
You are so aggressive.
Well, at least it was a good answer. Sometimes you sit here and stare at me and be like, oh.
It's alright, we've got Kate.
Well, okay, that you can.
What's this?
Yes,
Oh, I didn't know anything about it too.
Oh, go away.
Leave an answer. Right, I don't go to parents associate. You are.
Okay, the next two examples I promise aren't long. Can I move down now, Miss Kate?
Yes, you can.
Because you're looking at your phone, so I'm taking it you're done. Oops, why isn't that going down? Because I'm on the wrong thing.
No, you got busted.
Okay.
There's like addiction to that thing.
Okay, so, last questions. Okay, these questions we're going to need our calculator and we're going to be using solve.
I don't need to extend it.
I did not bring my calculator.
So these questions pretty much using the same formula as what we've been using, but it's asking us a different sort of question. So it's asking us, this is what we've ended up with, how did we get there? So how many years will it take for an investment of $2,000 paying compound interest at a rate of 6% per annum to grow above $3,000? So we're using the same sort of concept, but this time we've been given how much we end up with, and it's asking us how long did it take to get there. So first of all, we need to find our ratio. So to find our ratio, what do we do?
1 plus.
Yep, good start. Rate over 100.
1 plus 6 over 100.
Beautiful. So our ratio should be 1.06.
You got in your brain. It's just 6 and then you put, it's just.
Just move the decimal place 2 places. 6.2 places. It's Friday. You forgive me, I'll forgive you.
In the exam.